Let's continue talking about solving equations. We're going to start with an example. We have the formula 5x minus 3y equals 9, and we want to solve it for y. We can use the exact same steps that we've learned in the previous lesson. The only difference is we won't be able to get an actual number. Our answer will have variables or letters in it. So the first thing I need to do is get the term with y in it by itself. That means I have to get rid of that positive 5x. I'm going to do that by subtracting 5x from both sides. 5x minus 5x is 0, so on the left I'm just left with a negative 3y, and on the right I've got 9 minus 5x. Those are not like terms, so we can't combine them. And then to finish, I want to get rid of that negative 3. It's being multiplied by the y, and so I'm going to go through and I'm going to divide everything by negative 3. 9 divided by negative 3 is negative 3. Negative 5 divided by negative 3 is going to become a positive 5/3, and then we still have that x. And that's my final answer. I can't go any further with this. I don't have any like terms to combine. I have taken this formula and solved it for y. So let's do a couple more examples. In example B, we're going to try to solve for x. We want to get the x by itself. So I need to get the term by itself first. I have to get rid of that minus y. I'm going to do that by adding y to both sides. So now I've got ax equals p plus y. To finish, I want to get rid of the a. I'm going to have to divide by a. And there's actually two different ways we can write our answer. We can do the same thing we did in the last problem and just go through and divide everything by a. That gives me a final answer of x equal p over a plus y over a. Or, if you want to, you could just take both sides and divide it by a. You could actually make a long fraction bar to indicate that both the p and the y are being divided by a. And so you could write your answer as p plus y all over a. That means the exact same thing. Both of those answers are equally correct. Now, if I have a problem with a fraction in it, the very first thing I'm going to do is try to get rid of that fraction. 1/2 is the same thing as dividing by 2. To get rid of a 1/2, we can actually multiply both sides by 2. That gives me 2a, and then on the right-hand side, the 1/2 times 2, those 2's cancel out. Or in other words, 1/2 times 2 is 1. So I'm left with 2a equals b times h. To finish, if we're solving for b, I have to get rid of the h. I'm going to do that by dividing both sides by h. And then my final answer would be b equals 2a divided by h. All right, let's do one more that's similar. In example D, we are also solving for b. This problem at first glance looks a little bit more complicated, but it's actually very similar to what we've already done. The first thing we want to do is get the term that has the b in it by itself. That means I have to get rid of that plus r. I'm going to do that by subtracting it from both sides. Now to get the b by itself, I have to get rid of the 2 and the r squared, and both of those are being multiplied by b. So I actually can just divide by both of those things at the same time. I'm dividing by the 2, I'm dividing by the r squared, and then on the right-hand side, all I'm left with is the b. And so that's it. My final answer is b equals c minus r divided by 2r squared. Now the second type of equation I want to show you are equations that involve power functions that have exponents in it. So let's start with the equation x squared equals 9. To solve this equation, we're trying to figure out, well, what number squared equals 9? You might know what the number is off the top of your head. That's great. I'm going to show you a process that we can use when the problems get a little bit more complicated. So the idea is, if I want to get rid of a squared, I have to take the square root of both sides of that equation. That's going to give me x equal 3. 3 squared is 9. Now, technically in this case, there's actually two solutions, because x could also equal negative 3. If you take negative 3 and you square it, you also get positive 9. So this equation actually has two solutions to it. However, we're going over this technique because we're going to be using this a little bit later in Math 120, and we're going to be using it in the context of working with some exponential growth problems. In that particular context, all of the variables that we're going to work with are going to be positive, and so we're not going to worry about negative solutions. In example B, if we have a cubed and we want to get rid of an x cubed, we can actually take the cube root of both sides. That's how we can figure out what number cubed is 125. And with some trial and error, I can actually figure out that if I take 5 times 5 times 5, I get 125. So x is 5. This equation actually doesn't have another solution because if you were to plug in a negative number into a cubed, you would also get a negative. Now, let's say you don't know what the cube root of 125 is. Many calculators have cube root buttons on them. What that button's going to look like on your calculator depends on what kind of calculator you have, but usually it looks something like this. Now, and again, this depends on which kind of calculator you have. In some calculators, you're going to type in the 3 for the cube root first, and then that button, and then the 125. In other calculators, unfortunately, you do the operations in the opposite order. You would type in the 125, then that root button, and then the 3. And so maybe take a minute right now and try both of these orders and see which one gives you an answer of 5. 5 is the correct answer, and that'll tell you which way you have to type things into your calculator. And in fact, in problem C, I'm going to have to use a calculator to solve this problem. I've got y cubed equals 7. To get rid of the cubed, I have to take the cube root of both sides. So y is going to equal the cube root of 7. Now, the instructions in this problem said to give a decimal answer rounded to 3 places after the decimal. So I am going to have to go into a calculator to do that. I typed cube root of 7 into my calculator. On this calculator, it's an n root. That's the button I used. And if I want to round this to 3 places after the decimal, it's going to be 1.91. I have to round up 1.913. Now if I want to get rid of a 4th power, I can use the 4th root. So if p to the 4th equals 15, then p would equal the 4th root of 15. And once again, I will have to type this into a calculator to get my solution. Rounded to 3 places after the decimal, I got 1.968. Now as the equations get more complicated, you might have to do a little bit of work before you can use a root to solve. In example E, I have the equation 3z to the 7th equals 19. Before I can take that 7th root, I need to get that exponential, the thing with the exponent by itself. That's because that exponent of 7 doesn't actually apply to the 3. So I'm going to get rid of the 3 by dividing both sides by 3. So z to the 7th equals 19 thirds. Now I'm going to leave the 19 thirds as a fraction for now because I don't want to introduce rounding errors into the problem. To get rid of that 7th power, I have to take the 7th root of both sides. And so z is going to equal the 7th root of 19 thirds. And that's what I'm going to put into my calculator. 7th root of 19 thirds. Depending on your calculator, you might need to have parentheses around that 19 thirds. That gives me 1.302. All right, let's take a look at one more problem. In example F, I'm also going to have to isolate that exponential before I can take a root. So I want to get the parentheses and the exponential by itself first. In this case, that's going to mean dividing by 5. So 1 plus r to the 8th equals 37 fifths. Now, that 8th power applies to everything inside the parentheses, and we can't distribute exponents to sums and differences. We can't get rid of the parentheses, and so at this stage right now, we have to take the 8th root of both sides. Taking the 8th root is going to get rid of that 8th power, and we'll just be left with a 1 plus r. So at this stage, I'm going to go into my calculator, I'm going to figure out what that 8th root is, and then when I'm done with that, to finish the problem, I'm going to have to subtract 1, and that will give me my final answer here. So the 8th root of 37/5 is 1.284, and then to finish, I'm going to subtract that 1. So I'm going to do both of those steps in my calculator right now. And there's my final answer, 0.284. So the steps were, I had to isolate the thing with the exponent first. That was usually done by division. Then I used my root function to get rid of the exponent. And then in this case, I had to do a little bit of extra work to solve for that variable. That's it for this lesson. As always, let me know if you have any questions.